Okay, so Junior Roberts here again. We're on part 3 of our logic gates series. I've done parts 1 and 2 in previous videos. I will post a link in the description, and I will also include a link at the top of the screen so you can go ahead and check out those videos. So let's go right into part 3 of our logic gate series. Okay, so our learning objectives in this video will be to define the AND gate, derive the truth table for the AND gate, and to also formulate a Boolean expression for the AND gate. So we're going to start off by asking ourselves what is the AND gate and get an appreciation of what exactly the AND gate is. Okay, so the AND gate is a type of logic gate that accepts two logical values as input and produces a single logical value as its output. And again, just for a refresher, we can take a look at the logic gate symbol for the AND gate. And as we have discussed before in video 1 of our series, this is the symbol for the AND gate. It looks similar to the letter D in the word AND. So that's a good way for us to actually remember the symbol for the AND gate. And as it's displayed here, it takes in two inputs because these are the two inputs, and it produces a single output. Okay, so that's the symbol for the AND gate. Now, in terms of the function of the AND gate, the function of the AND gate is similar to that of us multiplying the logical values located at its input. So what we're saying is that the operation of the AND gate is similar to us multiplying the input. So whatever values we have at the input of the AND gate, if we multiply those values, we will get the logical output. And this will become clearer when we take a look at the truth table for the AND gate. Okay, so as we've said before, each logic gate has its own truth table and Boolean expression, and we're going to take a look first at the truth table for the AND gate. Okay, so the truth table for the AND gate. So a truth table is a table which shows the possible inputs and output for a logic gate, right? And here we have the truth table for the AND gate. So we have our input column A and our input column B, right, and our output X. So the reason why we have two columns for our input is because the AND gate takes in two inputs and produces a single output, right? So we have a B input and a A input. So B input is what we can consider to be our least significant bit, and input A our most significant bit. So in filling out the truth table, we're going to start with our least significant bit, and that's input B. And what we're going to do to fill out the truth table is that we're going to start with a 0 and then alternate our bits. So we'll start with 0, our logical value of 0, then we'll invert in the next row to a 1, and so on. And in our most significant bit, input A, we're going to alternate every 2 bits. So let me go ahead and start to fill out the table so you can exactly see a visual representation of what I just mentioned a while ago. So starting with input B, we will start with a 0, and then we're going to change to a 1, right? Then we're going to alternate again and change to a 0, alternate once more, and then we'll change to a 1. Then we'll go over to our input A column. We'll start with a 0, right? We'll keep the 0, then we're going to invert. So we'll get a 1, then we invert again and get a 1, right? Now, in terms of determining the output, again, we can think back to the operation of the AND gate, being in that it multiplies the input. So if we multiply 0 and 0, we get a 0. If we multiply 0 and a 1, we'll get a 0. If we multiply a 1 and a 0, we'll get a 0. And if we multiply 1 and 1, we will get a 1. Alright, so that's the truth table for the AND gate. And as we can see from the truth table, we will only get an output of 1 whenever we have both 1 at both inputs for the AND gate. So when we have a 1 at input A and a 1 at input B, we will get a 1 at the output for the AND gate. Okay, so let's quickly discuss the Boolean expression for the AND gate. Okay, so as we've said before, the AND gate function is similar to us multiplying the bits or the values that are present at the both inputs. So in this case, if we have input A, B, we can say that our output X would be equal to A, and this symbol here, this asterisk, represents AND. Alright, so we're saying that the output X is equal to A and B. Alright, so that's our Boolean expression for the AND gate. Alright, so let's quickly wrap what we have learned together just now. So what we've learned so far is that the AND gate is a type of logic gate that accepts two logical input and produces a single logical output. Now the AND gate produces a logical 1 at its input only when two logical 1 are present at its input. So we will only get a 1 as our output if we have both 1 at both of our inputs for the AND gate. Alright, and the Boolean expression which governs the AND gate is given as X, which is our output X, is equal to A and B. Okay, so this was Junior Roberts, again from realjuniorroberts.com. If there was anything in this video that you wish to get further clarification on, please post it in comments and I'll do my best to clear up any misconceptions for you. If you like this video, hit the like button, and if you think others would benefit, please go ahead and share so they can access this video. I post videos regularly, so if you want to be updated whenever I post new videos, please hit the subscribe button and the bell notification so you'll be notified whenever I post new videos like this. Thank you for watching.